Hello. Hi guys, good morning. Welcome back to the new video. In this video, we're going to see problem split linked list in parts. It's a not very. If you have watched the last three videos, last three daily videos, then you should be able to solve it. Why? Because it didn't like the concept of linked list is not much, but the concept actual behind concept is the main crux of this problem. Cool. Let's see the problem. We are having the head of a linked list and an integer k. Cool. We are having a head and an integer k. Now we have to split the linked list into k consecutive linked list parts. So we have to split the linked list into k consecutive. So in total, I should have let's imagine the nodes of this linked list as the balls and k as some integer, and we have to split into k consecutive balls. So basically I will put some k consecutive balls in some box, and I will just say, okay, I have all these k boxes in which I will be placing these balls, right? So I just want k consecutive linked list, as in I will have k boxes with me, and in this boxes I will be placing these balls as in I'm referring to the linked list nodes. Cool. The length of each part, now you saw that, okay, we have k parts or as in k boxes with us. Now for each part or each box, it should be as equal as possible. And when I say as equal, which means it should be as equal as possible to the every other box. Now when we say as equal, it means, okay, I can just say completely equal. If not completely equal, then a difference of 1. If not a difference of 1, then a difference of 2, and so on and so forth. So it just says, okay, as equal as possible. So first thing comes in our mind is, okay, it should be completely equal, which means all these k parts are exactly equal. And how we can do it? Let's say if I have a balls as 9 and I am asking you to put them in 3 boxes, so for sure you will put three balls in each box. And with this, your all the boxes have equal walls, so that's it's completely equal. Now it just says, okay, no two parts should have a size differing by more than 1. Now if not completely equal, he's saying that at max you can now place one ball. So basically the maximum size difference, it can be 1. So you saw, okay, here it is 4, here it is 3. So maximum size difference is 1. Here it's 4, here it's 4. Okay, it's 0. But yeah, maximum size difference is actually a 1. So that is the worst possible stuff which can happen. Again, up till so far, we have actually built the entire solution. That's the reason. Just line by line and keep understanding what's happening. Cool. And it may also lead to some parts being null. What it means is, okay, let's say if I ask you, I have 5 boxes and 3 balls. So for sure, you will firstly make these 5 boxes. In every box, you will place one ball. Then the remaining 2 boxes will be empty. So for sure, it will just say that, and it's the same example as you can see here itself. So it will just say, okay, some parts it can be empty or null as well, which means some boxes can be null or empty as well. Now, last part is the parts should be in the order of occurrences in the input list. Now, as you saw above, also we were placing 4 in the first box. So 4, it should be the 4 consecutive nodes of the linked list, and then the next 4 consecutive nodes of the linked list, and then next 3 consecutive nodes of the linked list. It should be the consecutive nodes of the linked list itself. And parts occurring earlier should have always size greater than that of the equal to the other parts occurring, and always it should be in the non increasing order, which means it should be in the decreasing order, which means more number of balls in the earlier, and then the lesser, and then the lesser, as like this it should happen. Cool. Now let's see, the main crux was how to place the balls. Now we know that, okay, we need to have k parts for sure. Let's have an example so that you understand that pretty well. I am saying my n is 11, which means my length, it is saying my length is 11. My length is 11, which means the number of balls or number of nodes in my linked list are 11. I have to distribute them into k parts. Now again, I am saying I will have 3 parts for sure, 3 boxes for sure. In these 3 boxes, I have to place these 11 balls. Again, if I ask you, let's place them equally. If I ask you, let's place them equally, no worries at all. Let's place all of them equally. All of them should be equal. So what you will do is, you have 11 balls. You know you have 3 boxes. 11 balls, 3 boxes. Each box will have 3 balls. It's a simple division. 11 by 3. Say, okay, I will have 3 balls. 11 balls, 3 boxes. Each box will have 3 balls. Or you can simple say, okay, 3 boxes should have 11 balls. One box should have 11 by 3 balls. Now 11 by 3, it should be have, every box should have it. Now we are having a simple division, so 3 balls should come in every box. That is it. Okay, so with this we know that, okay, each box should have 3 balls. Okay, great. 3 balls will be equally in every box. So I will just place 1 2 3 1 2 3 1 2 3. 3 balls in each box. 3 balls in each box. But you know that, okay, if a few balls were remaining, because 3 into 3 is 9, still 2 balls are remaining. So I'll just know, okay, what are the number of balls remaining? Number of balls remaining are 11 mod 3, which is actually 2. Just say, okay, how many number of balls are remaining, because it is not completely divisible by 3. Okay, 2 balls are remaining. Now you have to place these 2 balls, but you also want the difference at max should be 1. So you will just do one thing. Okay, place the first ball. Now first ball I place in the first box, because it was said that I cannot place the more number of balls in the end. I should place the more number of balls in the start, and then I should keep on reducing the number of balls. So I just did, okay, place the first ball here, again place the next ball here, again, and it will just keep on going. So you saw number of balls remaining were 2. So first ball in this box, first ball, next ball in this box, and then it's gone. That is how. Now when I say you have a linked list of these 11 nodes, so what you will do is you will just simply say, okay, Aryan, I know that every box, which means I have k boxes, which means for every box I will have nothing but these n by k. N equals to length by k number of nodes. So I know, okay, I need to put in n nodes. Okay, I will put in the n nodes, which is the 3 nodes, but I also have a remainder empty. So okay, one remainder empty, okay, one remainder used. Now one remainder is gone, only one ball is remaining, because one remainder is already used. Again, I will just go and ask you, bro, the next n balls I will take in. Okay, cool, next n balls you should take in, plus one remainder also you have to take in. Okay, one remainder you have to take in, because one remainder was remaining, because remainder you have to take in, and for sure one box, one remainder only, so as to just get it as close as possible. And that's the concept which I've taught earlier also. If you want to have some numbers as close as possible in some boxes, it is the only way. Just firstly have them equally divided, and then keep on placing 1 1 1 in the end. Cool. And then okay, it was 2 more again, sorry, 4 more again, 4 4 8 plus 4, 3 more again. Cool. Now you know that, okay, one remainder was there, so I just use one more ball, and it is one consecutive thing. Again, I wanted consecutive 4 nodes. I want consecutive 4 nodes. I want consecutive 3 nodes, right? So ultimately these will be my k parts or k boxes, and that's how I can simply get it solved. Again, for this question you have length as 10, k as 3, simply n, which means, okay, in every box how many number of balls will come in? It's actually 3, but remainder also I have a 1, so for sure the first box will have 3 balls, but 1 remainder will come in. Okay, next ball will have again 3 balls, because 3 balls is for sure in every box will come in. It's just a remainder will help us, okay, to know how many number of extra balls to add. It's just, it can be either 1 or 0. Now the until unless the remainder you have, just having it 1. As soon as the remainder goes away, so have it 0. Okay, it's 0. Again, for third box it's 3, and then the remaining is 0. Cool. As you will see that, again, to get the n as the number of balls in each box, so you got the number of balls in each box, which is length by k. Now it is length by number of boxes. K is number of boxes or number of parts, and it is the balls in each box. Cool. Let's quickly have a look at the code. It's exactly easy as what we discussed here itself. Very easy. Firstly, we have a vector of parts, which will have the start of every part of our linked list. Now firstly I have to get the length, so as to know, okay, because I know that, okay, how many balls should come in each part. For that I need to have a length by k, which means length by number of parts. So I need to have a length first, right? So I'll just simply get a length, although you can just get the length by iterating on this entire linked list up to just half, but it's not a much worry, because I have to anyhow go in the entire linked list again. So it is O of n plus n. If you had used a slow enough fast pointer, so it would have been O of n plus n by 2. Although you can just optimize this initial part by using a slow and fast pointer so as to get the entire length of the linked list, but that's not much of a concern for us, because it won't affect our complexity as much. Cool. Then as we saw above, that we will have a n, which means a number of which means saying, okay, n balls should for sure come in each of those k parts or k boxes. And what is r? R is nothing but the remainder. It will say, okay, until unless I have r, I will keep on placing one ball in the starting r boxes. One ball in the starting r boxes. Okay, cool. Now my n and r is done. Now I will just start building my entire like linked list kind of parts, right? So for that, I just went on from 0 to up to less than k, because I know I have to make for all k boxes or k parts, right? And then firstly, for start of the linked list, I have for the first part, because I have to go for k parts. For the first part, simply pointing it to the parts of I and keep pointing to the starting node of the linked list. But pointing to the starting node of the linked list, I should know up till when I should go, or up till where I should go. I know, okay, I have to go up till n and plus r as in 1 plus 1, but 1 only and only if r is there, right? Plus 1, but only and only if r is there. So I just did same thing. I know, okay, I have got the starting node, but where I have to go, because if I get the first linked list, but after that linked list and I have to place a null, so I should know, okay, up till where I should go, that okay, after that I will place a null. So I just went on up till n, and then I just placed, okay, if r is 0, then use that r, and ultimately use it. I am using that r. When I will go up, I have used that r also. So if the r is there, I will be using that r, and for sure I will just go into n plus 1 or n plus 0 length, and that 1 or 0 is depending upon the r remaining or not. Now when I have got this, first just assign, just moving on next node. Ultimately in the end, when n plus r length, or basically n plus 1 length or n plus 0 length is done, then I will just simply place, okay, this previous next pointer points to my null. And that's how you have got the first part of your linked list. And now your node is actually pointing to this end of this link, which is the next node it is pointing to. So now you can start off your next part with this next node and simply keep on repeating the entire process again. And that's how you can simply get it solved. Cool. The code is on. I hope that you guys take care. Bye bye.